Next, let's look at stage 2 in the reactive shaper. What abstract data refers to as a wavefolder, although its action is actually quite different than typical Buchla-like wavefolder. Indeed, the distinct does have a wavefolder mode 2D on it. So here's our normal sine wave. If I was to take that sine wave and run it through a typical wavefolder, this would be the resulting sound wave shape and spectra. I'll put the Moog in drone mode for now. There's our typical sine wave, but as I increase the folding amount, you can see how the waveform is repeated multiple times. And we get some interesting gaps in the harmonics, as well as emphasized higher harmonics. Now compare this to what the reactive shaper does. I'll take the distinct out of the circuit, get just the pure sine wave, back into our reactive shaper, turn on the Mother 32's VCA again, and start increasing its stage 2 wavefolder mount. Pretty early on, you see that's kind of how the input clipping did back in the first movie. It's taking the waveform over a certain threshold, reducing it greatly in voltage, and then recreating it at that lower voltage. It does have this interesting transition region right through here, very light folding amounts, where we start getting some additional noise in this signal as we're on a threshold. Go just past that, and lower harmonics get a little stronger. The result sounds like a cross between pulse width modulation and oscillator sync. Turn that off for now. Turn up our cutoff to make sure we're not reducing any of the harmonics going through it, and set up another simple arpeggio. I'll start by patching an envelope again into the stage 2 CV and start increasing that depth. Almost a little bit like a sync sound. A little bit of filter. Nice pluck sort of sound. We can mix in our original oscillator from the Moog. Do an octave offset. Or we can indeed treat it like pulse width modulation and feed it in an LFO instead. Here you want an initial offset to then vary around. With a very slow LFO and a fairly high depth, it now sounds almost like two detuned oscillators rather than just a single VCO. And again, you can still add in a second oscillator. Again, this gives different effects with different waveforms. That's the sine wave in. I'll change to our triangle wave. I'll try a few different octave offsets. I'll remove the modulation for now. Pure triangle. Here's some depth. Here's some envelope. A little shorter of a decay. I can swap around, and again, as in the case with most wave shapers, kind of an unusual effect on a square wave. I'll turn down the depth for now. There's a normal square wave. I hit a threshold where it's doing something very strange with the way it's trying to invert the top part of that square. Doesn't work so well with an enveloped amount. But what does work well is the classic tall-tooth wave. This is the unaffected saw. With some envelope. A little faster. Again, I have some filter going on this. I can open that up. And I can mix together stages 1 and 2. I'll go ahead and envelope stage 1. Get that nice pulse width Doppler sort of sound, and then add an LFO into our stage 2. Get a little intermediate amount here. That's actually a pretty fat coarse sound for one oscillator. You can filter it. Add a second oscillator in. Maybe drop this an octave. And go back to our sine wave. There it is by itself, no filter. A lot of harmonics for a sine wave.